Greetings everyone, my name is Katayun Sheikhi, and today on behalf of Group B24, I'm here to present a solution that holds the potential to reshape energy generation in Port Hope Simpson. Our research title is Design and Analysis of a Hybrid Power System for Port Hope Simpson Labrador. Our effort revolves around upgrading the electricity landscape through the strategic fusion of renewable resources with help of technology. Imagine a harmonious symphony where the sun's radiance, the wind's force, and the intelligent systems come together to compose a sustainable energy masterpiece. Our vision is to augment the existing system, which is diesel generator infrastructure, by seamlessly integrating solar panels, thereby forging a hybrid power system that works efficiently, reliably, and is environmental sustainable. Generating clean, reliable, and affordable energy is a global challenge, especially in rural areas. Hybrid renewable energy systems that combine sources like solar panels, wind turbines, and diesel generators offer a potent solution. By blending these sources, we overcome their individual limitations and ensure a steady power supply. These hybrid systems bring several benefits. Tapping into clean, abundant energy, reducing reliance on fossil fuels, enhancing system stability even during low renewable generation, and managing excess energy efficiently. In places like Newfoundland, many off-grid communities heavily depend on diesel generators, which comes with maintenance issues and environmental concerns. To address these challenges and create a sustainable energy solution, we are exploring a hybrid power system for Port Hope Simpson, a rural community which you can see in this picture. We aim to replace diesel reliance with renewable sources like solar and wind, which are cleaner and more reliable even during the outage. Using advanced tools like Homer Pro, we are designing a hybrid system tailored to Port Hope Simpson's resources by seamlessly integrating solar and wind along with energy storage and smart control strategies. We aim to boost reliability, efficiency, and cost effectiveness. This research provides a comprehensive analysis of our proposed hybrid power system, highlights its potentials to enhance energy supply, cut costs, and reduce environmental impacts compared to the current diesel and wind setup. Our research, which includes resource assessment, system design, and performance evaluation, sheds light on the advantages of introducing a hybrid power system in Port Hope Simpson. As we start our work, it is crucial to draw upon the information from prior studies. This literature review provides us with valuable insights, guiding us with the knowledge of studies that has been done before, because they have discovered that such systems comprising elements like photovoltaic PV systems, wind turbines, and diesel generators possesses the potential to surmount the limitations to individual technologies. Let me introduce some of these research studies. As you can see, in this table, we have gathered all the researches and the author, their year, the resources, the software, and the area. For example, a study conducted in the United Arab Emirates assessed the technology economic optimization of hybrid energy systems using tools like Homer Pro. This investigation underscored the power of combining different renewable resources, demonstrating a more efficient energy utilization. Another exploration into the autonomous hybrid wind solar PV system, unveiling the economic viability of such configurations under various cost scenarios. Moreover, a study in Sri Lanka showcased the economic feasibility of a hybrid energy system involving PV, wind, diesel generator, and battery technologies. These studies underscored the economic viability of such systems and the importance of government support to drive their adoption. We also have investigations that have closely examined the specific regions and challenges, like places that we are studying on, as Port Hope Simpson in Newfoundland. A hybrid power system was designed for the community of Francois, integrating PV systems, diesel generators, and batteries. These explorations illustrated the system's behavior under diverse scenarios, laying the foundation of our own analysis. Additionally, the utilization of floating solar PV was explored for energy sustainability in Mackillop, Newfoundland, demonstrating a remarkable reduction in diesel fuel consumption. These methodologies illuminate the path to optimizing hybrid power systems, ensuring maximum efficiency and cost effectiveness. It's a testimony to the power of technology and research in crafting resilient energy solutions.
My name is Olajide Michael. In this study, Homa Pro software and MATLAB Simulink were used for the design of a hybrid power system for Port Hope Simpson. The Homa Pro software was used for the sizing of the hybrid system, the economic study and optimization of the system, while MATLAB Simulink was used to study the dynamic response of the system and the control scheme performance of the system. The objective of this work is to design a hybrid power system for Port Hope Simpson to reduce the total reliance on diesel generation and costs of electricity generation in the area. And based on location geographical studies and resources available in Port Hope Simpson, wind and solar system resources are believed to be the most visible approach to electricity generation in addition to the traditionally available diesel generators in the area. OMA's flexibility makes it helpful in evaluating this design, as its results help us to get a general overview of the design system in terms of cost savings from the previous system, equipment usage, operation and maintenance, and overall system optimization. Wind and solar energy were chosen due to location suitability, and the MATLAB was used to design what? The system response. Port Hope Simpson is one of the remote communities in Newfoundland and Labrador that rely heavily on fossil fuel for electricity generation. It is located in southern Labrador around the Alexis rivers and with a population of 403 as of 2021. There are currently 3 installed diesel generators in Port Hope Simpson, which consume more than 836,760 liters of fuel annually. The ever-increasing high cost of diesel and transportation due to the frozen Labrador Sea and iceberg during winter is a significant challenge for the people of Port Hope Simpson. As a result of this, government of Newfoundland and Labrador has to continuously subsidize electricity for domestic usage by 75%, which cannot be sustained for long. As a result, consequently, an alternative hybrid method of electricity is needed. The key sectors that were considered in designing an hybrid power system for Port Hope Simpson were shown in the past chart in the slide. They were communities and government, shopping, hotels and travel, automotive, industry, restaurants, sports and activities, education, professional services, religion, postal services, and others which take 3.5%. Data were collected from NL Hydro. They are the one that operate and maintain the power system in Port Hope Simpson. The annual load profile and diesel consumption data were gotten from them, and likewise the single line diagram. Port Hope Simpson power station houses 3 diesel generators with a capacity of 725 kilowatts, 545 kilowatts, and 430 kilowatts. as shown in the single line diagram, and they operate N1 philosophy, meaning two works at a time and one is on standby. The current electricity generation of Port Hope Simpson is 1,775 kilowatts from the three generators, and the operating cost is $1.62 million per year. The post-hole system will consist of wind turbine, solar panel, storage system, generator, and a converter, as shown in the schematic diagram below. And we propose adding 1,414 kilowatt of PV, 1,571 kilowatt of battery capacity, and 1,600 kilowatt of wind generation capacity. This will reduce the operating costs from $1.6 million per year to $695,883 per year. And the investment should have a payback of 2.867 per year and an IRR of 34 point. In the proposed system, the generation sources will be from wind, solar, and diesel generator as shown in the electrical load diagram. Electrical analysis. The diagram here is showing the daily load profile, seasonal profile, and yearly profile of Port Hope Simpson as gotten from the latitude and longitude of the study location was used to estimate the available solar irradiation and the average wind speed with the help of Omar's Pro software. From this figure, we could see that the highest solar radiation was gotten in the month of May, while the lowest was in the month of December. The solar PV array that was used in this study is Canadian Solar Max Power CXCX 325P. The specification of the wind turbine used in this model is 100 kilowatt EXO M21 AC wind turbine developed by Iosaku. The average wind speed and profile curve for the wind turbine as shown in the two figures here, respectively. The highest wind speed was found in the month of December, as we could see from the diagram, and while the lowest wind speed was in the month of July.
Hello, my name is Obama Endurance Osas. I am standing on existing protocol. My presentation today will be focused on the result aspect of these design projects. Having collected data from NLHydro, our team was able to analyze and process this data with the use of Omar MATLAB software, considering its sensitivity variables such as wind speed and solar irradiance and other environmental factors to design a robust system that will serve Port Hope Simpson. The result analysis will be explained further in the subsequent slide of this presentation. Having analyzed our data with the aid of Omar software, the software gave us a series of recommended optimized results, which our team have set to go for the second option, which has a wind turbine, a solar PV, a generator set, a converter, as well as a battery storage system. Also, we have also seen a second table which shows the base system, which is the original system in Port Hope Simpson, that houses three generators set for their power needs, and the current proposed system, which is going to be an hybrid system. We have also seen from this comparison that the NPC for the present proposed system is cheaper compared to the existing system, which shows that this hybrid system will bring a lot of cost savings to the power needs of Port Hope Simpson. The result charts on this slide shows a cash flow comparison between the current system in Port Hope Simpson and the proposed design system. We can observe that there is a wide margin between the two different systems. From this chart, we can also conclude that based on the cash flow charts, that the return on investment with the use of this design hybrid system will be far better than the previous existing system. This slide shows the overall block diagram as simulated with MATLAB Simulink software. A major component of this block diagram are the solar PV, the wind turbine, the generator sets, our diodes, as well as our battery storage system. The subsequent slide will show the outputs for this simulation and shall be explained accordingly. This slide shows the results of the state of charge, the voltage, and the current. We can observe from this chart that the state of charge displays the proper characteristics of a DC, while the voltage and current outputs have a proper sinusoidal wave, which makes this system simulated to be very okay and acceptable. This chart shows our signal statistics. With this, we are able to analyze the system to know the best control method for the system, which makes this output a very vital result in this simulation. The final aspect of our MATLAB Simulink results is shown in this 6 curve, which is the overall system response as derived from our last scope 4 of this simulation. From the analysis carried out so far in our design projects, our team will recommend the use of hybrid energy system for Port of Simpson. Reason because an hybrid energy system in Port of Simpson will improve the energy reliability, it will reduce the operational cost as well as lower the environmental impacts as compared to the use of diesel generator sets. Also, the resource assessment also show that wind and solar resources are sustainable, and also from our cost comparison, we notice that the use of hybrid energy system is far cheaper in terms of cost compared to the existing system, which utilize a lot of diesel, which are more expensive on a daily basis. In conclusion, we would say that integrating solar panel and wind turbine with the existing diesel generator setup will be a best form of energy generation for Port of Season. Also, our feasibility study has also shown us that the wind and the solar irradiance are readily available in Port of Season, which makes it easy to generate using this additional source of energy. And in the aspect of the benefits of using this hybrid energy system, it can help us to reduce the use of fossil fuels, which currently amounts to over 800,000 liters annually. And also, it will help to provide stable electricity supply for Port of Simpson. In the economy aspect also, we suggest we use hybrid energy system because it will save a lot of cost compared to the base system as shown from our HOMA analysis based on their costs. Also, we will promote sustainable energy solution for rural communities because this is cheap and also this is a clean source of energy.